Welcome back to part 2. What is Scorekeeper? So Scorekeeper is an R package with a suite of tools for transforming data, and it's based off of dplyr functionality. The primary function of Scorekeeper is the scorekeep function, but there are also several other functions that are working in the background to make scorekeep work. So overall, the scorekeep function that you're going to use has 2 arguments. It includes a raw data file and a score sheet. And we're going to talk about what that score sheet is in just a minute. The scorekeep function returns a clean data set based on the arguments that are specified in that score sheet. And so you might be wondering at this point, what is a score sheet and what does it look like? And a score sheet is an 11-column table, data frame. It could be in .csv, .excel, .rdata, as long as you can read it in. Though I will say .csv, .excel are probably the easiest, and that is because it assumes that all of your inputs are either character or numeric and not vectors or lists on their own. So you can pull in a .csv, pull in a .excel, and make it an R data frame, but it takes a little bit of extra work to natively derive that R data. So I would just recommend starting out with a CSV and Excel file, and that would be the easiest way to start. Now, all of these columns may not be required depending on the needs of your particular score sheet and what operations you have. But for me, I just like to start out with any score sheet that I am building up. I'm going to start out with those 11 columns. I know that I'm not going to need any more than that. I might not need a couple of them, but I'm going to have them there just in case. And some of them, as you might see here, the first, so val_labs and new vals, those are both NAs all the way down. Doesn't matter that they're there, but we have them in case we were to need them in the future for another step. Okay, so let's talk about the score sheet columns. So there are 11 columns, as you just saw, and I'm going to talk about the first 5 in this slide, the next 6 in the following slide. So the first column is that raw_vars column, and this is a raw variable or a list of raw variables that can be either a single character string if it's one variable, or a comma-separated character string if it's multiple variables that are needed for an operation. So anything that is a raw variable that you're going to be using for that particular transformation, you're going to put it in the raw vars column. The new _var column is the desired name of a new variable that is created during the operation. So this actually needs to be a different and new name than your raw variables. It needs to be a name that is not currently in the data set. You can make it whatever you want. We can rename it later, but right now it needs to be something that is a new variable name. The next thing is a label. So if you want to label your variable, or there are certain operations that kind of prefer that you have a variable label and say what it is, then you will put the label right there in that label column. The next is the operation, and this is the operation to perform. There are several operations that are available right now in the Scorekeeper package, and I'm going to talk about what those are in a couple of slides as well. And then the next column, column 5, is our step, and that is the order of operations to perform, starting with 1. I actually enter all of my raw metadata for whatever measure that I'm using. I enter that as step 0. It is not required for the score sheet. It doesn't matter that it's there, but it helps me with organizing my metadata for that score sheet. So I will first write everything out as, here are my raw variables, and I'm going to put them in step 0. I'm going to say what their labels are, all of that, and then I'm going to move on to 1, 2, 3, 4, which is where the juice gets squeezed in the score sheet. Column 6 is your value labels, or val_labs, and this is the value labels that you have for a new variable. For instance, if never was equal to 1 in my original data and I'm transforming it and recoding it to be equal to 0, I would put never equals 0 in that val labs column. The number 7 is your new vals column. So this is if you were recoding that never from 1 to 0, you would put 1 equals 0 to show that your old ones are going to be new zeros. And the next 3 columns, if condition, if true return, else return, 8, 9, and 10 are all columns that you only need to fill out for an if-else operation. So if you are doing that specific operation, you would need to fill out 8, 9, and 10. Otherwise, just put NAs, leave them blank, whatever you want to do. And 11 is code, and this is just required if you're doing a filter at or case when operation, not needed for other operations, but the easiest way to get them in for those 2. Now I'm going to talk just for a couple of minutes about these operations. You can find a lot more detail about these operations both by looking at the dplyr and tidyverse manuals if you don't know how they are typically made in the dplyr functionality, as well as looking at the reference documents and the help for the Scorekeeper package. So use that documentation, use that help package, use that information that is online for Scorekeeper to dive a little bit deeper into the operations. The current operations that we have supported are select, which selects columns of a data set. So again, character string that is comma separated, just write out all those columns that you want and it will select those columns. Filter at will filter rows of a data set, and you can find out how to specifically write that code that's going to go in that column 11 for a filter at by looking at the Scorekeeper documentation. Recode will recode a variable into a new variable, and we've talked a little bit about that and what that might look like. Sum will sum the variables identified in your raw variables column. In addition to the raw sum, it's also going to create 4 additional new variables, including the complete case sums, the number and proportion of NA values in that sum, so the number of missing values that are included in the sum for not the complete cases, and a weighted sum that is based on the number of variables in that sum. So you're going to get 5 variables out of that sum function if you run it. The next is a mean. You're going to get 4 variables for the mean function. You're going to get your, in general, your mean. You're also going to get the mean of complete cases only and the number or proportion of NA values in the mean. If else creates a new variable that follows if else logic, so that so you identify what your if condition is, and then if true return and else return, it's going to follow that logic. Case when creates a new variable following case when logic, and rename will rename a variable.